Hi everyone, so welcome to today's session. In today's session, we are going to learn about how to make LED work with the help of a microcontroller. So this platform is called as Tinkercad. At the very top towards the very left, you can change the name. So I'm just writing LED. Alright, now for this we need a microcontroller. Microcontroller is similar to our brain. Microcontroller help us to process the signal and provide us with the required output. This microcontroller is Arduino Uno. Why I have taken Arduino Uno? Because it is beginners friendly. As you can see over here, we are having the analog pin from A0 to A5, as well as we are having digital pin which starts from 0 over here till 13 pin. So we have total of 14 digital pin, and we have couple of grounds. Here you can see one ground, second, third. We also have 5 volt, 3.3 volt V in, and you can also see the RX-TX signal. This special sign indicate for pulse with modulated signal. So there are a couple of pins such as 3, 5, 6, 9, 11 and 10 which are pulse width modulated. So we are having a microcontroller. Now we need to take an LED. You can take any LED of your choice. If you want, you can also change the color. So I'm taking green. Now, just to make sure that the current supplied to it is not more than 20 milliampere, I am taking a resistor. You can also choose the value. I'm taking a standard value of 220 kilo. Let's take a 220 ohm. Now, this LED is having two terminals. One is the cathode, another is the anode. So cathode terminal is the negative terminal. Now, whenever you want to connect and glow the LED, you need to connect the cathode side, which is the negative side, to the ground, and anode side, which is the positive side, to the high supply. So let's take this LED. Let's try to connect it to this resistor. Why we are trying to connect it to the resistor? So that the flow of the current does not reaches an value of 20 microampere. It just increases the longevity of this particular LED. That's the reason only. Now we need to connect the cathode side to the negative side. So I have a ground. So let's connect it to this ground. Now we can connect the anode side to any of these pins. So I'm just attaching it to pin number 7. This is a very simple LED diagram. Now after doing this, we also need to provide the source power supply to our Arduino. So we can just connect this positive side to the 5 volt and this negative side. So for negative I'm taking black to the ground. There are various ways how you can provide supply. So we can also provide it through the adapter over here. We can also provide it through this USB port. We can also provide through the battery. Now, this is a basic construction. Now let's come to the coding part. In the coding part, once when you click on the writer side, we get a couple of options in the Tinkercad. Like you can proceed with block code, block plus text or text. So let's start with the very basic, which is the block code. So in block code, what we need to do, we need to provide the high supply to the positive side, which is the anode side. So you have to look for what is the pin number. So the pin number is 7. So let's go to code. So forever, set built-in LED high. Wait 1 second. Set built-in LED low. So let's just remove this. So since we are already having the control, we'll just put in our required instruction, which is we want to give high supply to the pin number 7. So I'll drag this. Pin number 7 is getting high. Now we need to wait for some time. And then we want to make sure that this particular pin gets switched off. So we now need to provide a low to pin. So set pin number 7 to a low, and we also need to again wait for some time. Why we are waiting? So that it gives us a blinking effect. Now let's see. This is our code. Let's see whether it works or not. The code is initializing. Now you can see the timer also has started and you can see blinking of an LED. Similarly, what you can do, we can stretch it out and we can attach a couple of more LEDs. Just stop the simulation and just take few more LEDs. You can just connect it to anywhere. We'll just quickly create this. Since all of it is negative, I can just provide it a common. I'm just trying to keep my circuit clean. Okay, now we need to provide two different ways so that we can control all of them at different time. If you want, you can also again provide it to line number 7, which is pin number 7. But then if any effect happens to one LED, the same thing will happen to another. So this is 6 and 5. Now I'll change the color of this. Okay, so we can come to code again. I'll just copy these. Instead of 6, I'll make it 5 and 6. So I'll just again use this. I'll duplicate it. And I'll make this 6 to 5. So now this is our code. High, low, high, low, high, low, and 7, 7, 6, 6, 5, 5. So let's start simulation. So one by one is what it is happening. Okay. Now, why it is happening one by one? Because the code goes from the top to the bottom. So it is going to read first 7, then 6th pin, then the 5th pin. That's the reason. Okay. So if you want to see how does this code look like when you are trying to do it in text-based coding, so simply you have to go at the very top, you have to select the text. Now continue. Yes. So in C, or you could say embedded C, what happens? There's a predefined skeleton structure. So the skeleton structure is you have to write what are the pins you're using. So for that, inside the void setup, we mention the pin mode. And we mention whether it is an output or an input device. Later on in the void loop, we provide the logic of particular program. So here it's a very simple logic. We just want to provide high to anode pin. So we are writing a digital write. With the help of digital write, we are just providing 7 high, 7 low, 6 high, 6 low, 5 high, 5 low. Very simple. If you want to see both of them together, just click on block plus text. So you will see all of it all together. Right now, I have already shown you initial block code. So that's it. I hope this is clear. Thank you so much.